Okay, so in 4.3, it's the addition elimination method. And this is another way that we can use, or another technique, strategy we can use for solving systems of equations. So we're going to work a few problems from the chapter review, which is on page 339 in your textbook under section 4.3. We're going to look at problem 25 and number 34. So first, number 25. The goal of the addition-elimination method, I call it the elimination method because I'm literally eliminating one of these variables. Either I'm eliminating the x or I'm eliminating the y. And I always go for the one whose coefficients are the same. And if I need to do extra work, like I need the coefficients to be the same, but their signs to be opposite. So this could be a plus sign, but I need this one to really be a minus sign. So if I look at the x, this x has a coefficient of 1. This one has a coefficient of 2. Okay. The coefficient on this y is 1, and the coefficient on this other y is 1. Therefore, I'm going to eliminate the y. So I'm going to eliminate y. Okay? Which means I need now the signs to be opposite. And since the coefficients are equal, I need their signs to be opposite. This one's a positive, and how can I make this one a negative? By multiplying the entire equation by -1. Okay, if I do that, my equations become x plus y equals 6, and negative 2x minus y equals -8. And then from there, I'm going to add the two equations together. So this is a 1x plus negative 2x is going to give me negative x. And then y plus a negative y is really going to give me 0y. And 0 times anything is 0, so it's gone. So the y's are eliminated. Equals, well, 6 plus -8 is -2. Then I have to solve this equation. So by eliminating the y's, I end up with an equation that's only in one variable, which means I can solve it. So I need to solve this for x, which means I need its coefficient to be a positive 1. So I'm going to divide by -1, and I'm going to divide by -1, and I get x equals positive 2. Good, but I'm not done yet. I still got to figure out the y. So I can take x equals positive 2, and I can plug it into any equations. I can plug it into this one, or this one, and solve for y, and I'll get the same answer. Now I'm going to plug it into the first one. So I have x plus y, if I can write today, x plus y equals 6, which means I have 2 plus y equals 6. So y equals 4. And the solution to this system is 2, 4. And then how can I check this? How can I check this? I can take this answer, 2, 4, and plug it into each equation to make sure it works. If I take 2, 4 and plug it into the first equation, I'll have 2 plus 4 equals 6. Does 2 plus 4 equal 6? Yes, so it works. If I plug it into the second, I'll have 2 times 2 plus 4. Does that equal 8? Well, 2 times 2 is 4, plus 4 is 8. So 8 equals 8, therefore it works. Awesome. Now let's look at number 34 because it's different from number 25. The difference here is the first equation. So let me label this 1, label this 2. The first equation, I need to have both of my variables on the same side of the equal sign, which means I need that 8y to go from the right side over to the left side. So this 8y needs to go from the right side over to the left side. And how do you do that? Well, it's a positive 8y, which means I'm going to subtract it. So my system becomes 2x minus 8y equals 24. And then I write down the other equation. I got 3x plus 5y equals 2. Oh no, equals 2. Good. Now, unlike the other problem, my coefficients were the same. All I had to do was change the sign, right? Over here, my coefficient for my x's do not match up, and the coefficients for my y's also do not match up. So from here, it's my choice. I can eliminate the x, or I can eliminate the y. It's the same amount of work. How about we eliminate the x's? Okay. In order for us to eliminate the x's, I need the coefficients to be equal. Equal, but opposite signs. One's positive, one's negative. Well, what's the smallest multiple that 2 and 3 share? I believe it's 6, which means I'm going to take this first equation, and I'm going to multiply it by a positive 3. Okay, 3 times 2, that will give me 6. In the second equation, I'm going to multiply by a 2, but it needs to be negative, so it's a negative 2. That would still give me a 6 as a coefficient, but it's really a negative 6. So we're both 6. This is a positive 6. This is a negative 6. That means I'll be able to eliminate my x's. All right, so let's do that. So this becomes 6x minus 24y, because don't forget that 3 needs to multiply everything, equals 72. Good. And then this one turns into negative 6x minus 10y equals negative 4. Great. And then from there, you add the two together, add your two equations together. 6x plus negative 6x, well, they cancel. And I get negative 24 plus negative 10y is going to be negative 34y equals, well, 72 minus 4 is 68. Good. And then how do you isolate y? You got to divide by negative 34. Divide by negative 34. And you get y equals negative 2. Okay, but you're not done. You're going to take y equals negative 2, and you're going to plug it back into any one of these equations and solve for x. I'm going to plug it back into the first one, since x is kind of already by himself, right? So I have 2x equals 8 times negative 2. 8 times negative 2 plus 24. And that gives me 2x equals negative 16. What's wrong with this pen today? Negative 16 plus 24. That doesn't look like a 6, does it? Let's fix that. Okay. 1 second. $16. Okay, so then I have 2x equals what? 8. Divide by 2, divide by 2, x equals 4. So the solution is 4 comma negative 2. Sorry, my pen's not calibrated today. For some odd reason, it's not writing what I write. So the answer is 4 comma negative 2. And again, how can you check this to make sure it's actually correct? You're going to take the solution and plug it into both equations, and they should come out to be true. Negative 2. All right, let me know if you have any questions.